morning dear student. Today now we are going to see the balancing of multi-cylinder engine, right? You see this problem in an inline 6-cylinder engine working on 2-stroke cycle. The cylinders center lines are spaced 600 mm, that 600 mm. In the end view, the cranks are 60 degree apart and in the firing order of 1, 4, 5, 2, 3, 6. The stroke of each piston is 400 mm and the connecting rod length is 1 meter length. The mass of the reciprocating part is 200 kg per cylinder, right? And the rotating part 100 kg per crank. The engine rotates at 300 rpm. Examine the engine for the balancing of primary and secondary force and couples, and also find the maximum unbalanced force and forces and couples. First to write the given data. So the length of the connecting rod L is equal to right, it is 400 mm, right? So radius of the crank is equal to L by 2, that is 400 by 2, that is 200 mm, right? The length of the each piston is 400 mm, right? Then connecting rod length, that is small l equal to 1 meter or 1000 mm. So the mass of the reciprocating part M1 equal to 200 kg, that is, then mass of the rotating part per crank is 100 kg, right? So the engine speed equal to 300 rpm. So now you calculate the omega equal to 2 pi n divided by 16, that is equal to 2 into 5 into 300 divided by 16, that is equal to omega equal to 31.42 radians per second, right? So now you draw the position diagram and crank diagram of the 6-cylinder inline engine, right? So here, so the E, that is equal to position of planes of cylinder. Position of planes of cylinder is nothing but, so there are 6 cylinders, right? Right. So this is cylinder 1, 2, 3, 4, 5 and 6. So each cylinder, the distance is 600 mm. So it is clearly given the cylinder, the center lines are spaced 600 mm. So it is here it is 600 mm, right? So I take a center plane, center of this entire system, I take it as a reference. I take the 4th cylinder. So this is a reference plane. This side is positive and the left side is negative, right? So next, the angular position of the diagram, first you dot a mark, right? For first cylinder, always in vertical, right? So vertical, the first cylinder, right? What is the next cylinder order? fourth cylinder. So fourth cylinder, it is 60 degree upward. So you see this 60 degree upward, the theta equal to 60 degree of upward each cylinder, right? So this is a fourth cylinder, right? So the distance is 60 degree, right? Next one is a fifth cylinder, right? Second order fifth cylinder. This is also 60, right? Then third cylinder, sorry, second cylinder, third cylinder, and sixth cylinder. So each cylinder having 60 degree apart. Okay, right? So this is called a primary. This is a B, that is a primary crank position. So now we go to draw the table, right? It is a very important one, right? Right. So first you plane mass kg, that is mass. So totally you take m1 plus m2 for m1 plus m2, you take it both. You consider reciprocating mass as well as the rotating mass, right? The radius of rotation, radius r, then centrifugal force divided by omega square, that is m into r, right? So distance from reference plane, that is L, right? Then centrifugal couple cc divided by omega square, so mr into L, right? First you should draw the table, is a very important. So how many planes? There are 6 planes. So 1, 2, 3, 4, 5, 6. So mass, total mass, here it is a 200 kg, here it is a 100 kg. So totally, so it is a 300 kg. You take it, right? So 300, 300, 300, 300, 300, and 300. So radius of rotation, you know that it is 200 mm. Here it is clearly given. So you substitute it here, right? That is 200 mm, right? So 0 0.2, 0 0.2, 0 0.2, 0 0.2, 0 0.2, and 0 0.2, right? Next, what is the centrifugal force? Multiplication of mass into radius. Mass in terms of kg, radius in terms of meter. So you are getting kg meter, you are getting the centrifugal force. So 0.2 into 300, you are getting 40. So 40, right? Sorry, 60, 60, 60, 60, 60, and 60, you are getting that, right? Next, I take a center plane as a reference. So center plane as a reference, I take this is center plane. We are taking it as center plane as a reference, right? This is a reference plane, right? Right. So above the values are negative, below the values are positive. So from the here you see this from this to this, what is the distance? It is 300 mm. So minus 300 mm, right? Minus 300 mm. From here to reference plane to second plane, so 0.9 meter, the 900 mm. For reference plane to the first plane, it is 1.5 meter, that is 1500 minus 1500 mm. So minus 1.5 meter, right? So minus 0.9 meter, minus 0. So minus 0.9 0.3 meter. So from reference end to fourth plane, there is a fourth cylinder, so it is a positive, it is 0.3. For a second at the fifth plane, also positive, so 600 plus 300 is 900, so plus 900, so 0.9 meter. Then the last plane, sixth plane, so 600 plus 1200 plus 300, 1500, so totally 1.5 meter. So multiplication of centrifugal force into distance, you are getting the centrifugal force and distance, you are getting the centrifugal couple. So it is a first 90, so minus 54, then 60 into 0.3 minus 80, so here it is a plus 18, here a plus 54 plus 90, you are getting that. So from this table, you should go to draw the primary force polygon using this table value, and primary couple polygon using this table value, right? Okay, so next you go to draw the couple values. How do you draw it? You just see it, right? So mark a point, any one point here, right? Right. So mark a point, just to draw the A primary force polygon and primary couple polygon B, right? You should draw it, right? So first to take mark a point, simple point, right? So from this point, so according to the firing order you should draw it, right? So firing order, so 1 4 or 1 6 1 4 5 2 3 6, so 1 4 5 2 3 and 6, according to this firing order you should try. So what is the 1? So 1 is a 60, so a 60. So what is the position of this angular position? So angular position is always in vertical, you see this. So angular position is always in vertical, right? So you see this diagram very clearly, show it, the angular position of the diagram, right? Right. So from this things you go to draw it, right? So okay, it is 60, I take 6 centimeter, so it is always in vertical position, so you saw draw it in vertically upward direction. I take 3 centimeter, right? I take 3 centimeter, 60 centrifugal force kg meter equal to, I take 3 centimeter in exactly vertical outward direction, right? So this A point, this is a B point, so 60, right? So what is the next one immediately? So firing order, fourth order firing order, you see this always 60. So according to the angle, 60 degree angle, so right, so draw a one horizontal line and draw a one 60 degree line from this point, right, towards upward direction. So this one, see this angle is 60 degree, right? What is the next firing order? The fifth, what is the fifth value? It is also 60. So 60, then you draw a one horizontal line. So it is downward. You see this angular position diagram. The fifth cylinder is in downward direction. You saw draw it in downward direction, right? So this angle is, so according to this you should draw it, right? So not an angle, according to this position, right? So you have to take parallelism, so you draw it here, right, at 60 couple angle. Now next firing order is second one. So second order is downward direction, then you draw it in downward direction, right. It is also 60, right. E point you are getting. So next third cylinder firing order. So firing you see this position of the angular position. So take the scale and scroll it, then you draw it here. So it is 60. Then the sixth cylinder firing order, you just close it, right. You are getting the closed primary polygon. So according to this diagram, there is no unbalanced forces forces produced due to the primary force polygon. So next you draw the primary couple polygon, is a very important one, right. So you see this table is very clearly mentioned that, right. So these values are negative, these values are positive. So according to these positive and negative and this position, you should draw the couple polygon, right. First you mark a point here. So according to the firing order, so firing order you know that 1, 4, 5, 2, 3 and 6, right. So first the first one is 90 minus 90, but you see this first cylinder, it is upward direction, you should draw the line in downward direction because it is a negative. So negative, I draw it particular scale, I take 4 centimeter or 3 centimeter, according to your scale you take it 4 centimeter, I take 4 centimeter, right. So minus 90, so A to B for cylinder 1. So next minus 54, sorry, so fourth cylinder. What is a fourth cylinder? Fourth cylinder is in you see this in upward direction, but the value is plus 18. So you should draw in plus 18 in upward direction. Parallel to this you should draw it. So parallel to this you should draw it in upward direction, right. 18, right. Fourth cylinder. Next fifth cylinder. So fifth cylinder you see this in downward direction, the value is 54. So you should draw it in 54, right. 54, right. So next what is a second cylinder? So second cylinder you see this second cylinder in downward direction, but the value is negative. So it is in downward direction. If it is value is negative, mean you should draw in opposite direction. It is a upward direction. It is a down now. According to angular position, it is downward direction, but the value is negative. So you should draw the line in upward direction, right. So parallel to this you should draw it, right. So it is minus 54, right. So next the third cylinder you should take. Third cylinder you see this third cylinder is in downward direction, but value is in minus 18. You should draw the line in upward direction. So it is parallel to this third cylinder angular position, right. Draw on outward direction, draw in upward direction, right, right. So minus 18, right. So finally you see the sixth cylinder is finally sixth cylinder, you should draw it. So close it, right. So finally you are getting the closed polygon, right. Finally you are getting the closed polygon. So that is this 90, so plus 90, right. So both the primary and the primary force and the primary couple polygons are completely closed. There is no unbalanced primary and couple polygon, okay. So next you go to draw the secondary unbalanced force and couple polygon, right. So just you go to draw the diagram once again, right. Just to fill up it, if you want to draw the secondary and secondary force and couple polygon, again you go to draw the table. So the plane, right, plane, right, mass kg, and radius of rotation r, then centrifugal force divided by omega square, so m into r, you are getting that centrifugal force, then distance from the reference plane, distance from the reference plane, that is L, right. So then centrifugal couple divided by omega square, so m r L, right. So complete the table. Okay, now we write the plane 1, 2, 3, 4, 5 and 6 mass. So if you want to draw the secondary and couple and force polygon, you should take only the 200 mm mass. So what is the 200 mm mass? So it is nothing but, so it is a reciprocating mass, you should take it only. So 200 200 200 200 200 200. So what is the radius of rotation? Is always 200 mm, so 0.2 meter, that is meter. So multiplication of both, you are getting 40, centrifugal force 40 40 40 40 and 40. So distance from the reference plane as it is. So here it is a center point, center is a reference plane, right. Now you fill up it. This is minus 1.5, minus 0.9, right, minus 0.3, 0.3, 0.9, 1. Then multiplication of things, multiplication of centrifugal force with the distance, you are getting the centrifugal couple. So minus 60, minus 60, minus 36, minus 12, 12, 36 and 60, you are getting that. So from these, from this table and these values, you should draw the polygons, right. So before that, so you should before going to draw the secondary force and couple polygon, you should draw the angular position. So angular position already according to the secondary balancing, secondary balancing. So theta is converted into 2 theta. So the angular position of the each cylinder. So the first cylinder is always in vertical, right. So cylinder 1. So according to the first diagram, then yes, now you see this diagram very clearly represent that, right. So the first cylinder is always in vertical. So now it is a 0. So 2 theta is always 0, right. Then the fourth cylinder, right, the fourth cylinder, so the crank is rotating this direction, right. So the force is 60, 260, that is nothing but 120, so 120 degree. So here it is a fourth cylinder. So it is a 120 degree angle, right? Next, fifth cylinder. So fifth cylinder location is 360. So 360 into 2, you are getting 720. So 720 minus 360, 60, you are getting 720 minus 360. You take the calculator and substitute it. So according to the angular position diagram, right, 720 minus 360, you are getting again the 360, then minus, right, here the angle is, you are getting this here, right? So this is a fifth cylinder, right? Next, second cylinder. So second cylinder is 180. According to this position, it is a 180. So 2 theta, again it is 360. It is 2 here, right? Then third cylinder here. Then sixth cylinder here. That's it. So this is the secondary angular position diagram of the six cylinder inline engine. Secondary angular position. So from this secondary angular position, you should draw the force polygon and the couple polygon, right? Okay. First you draw the force polygon, right? So force polygon, for the values are 40, 40, 40, 40, right? So mark a point here, any one point here. So secondary force polygon, you should draw it, right? So here mark a point here, right? So 40, I take 4 centimeter from my scale, or 2 centimeter from my scale, right? So according to this angular position, for first cylinder is 40 in upward direction. So I take 2 centimeter, it is upward direction. A, this B, it is 40, this 40 here, right? Because it is in upward direction. Next, immediately according to the firing order, right? So what is the next one? So according to the firing order, 1, 4, or otherwise you can draw it in according to this angular position, nothing else, right? Again you should draw into upward direction here. So it is the space is not enough, you just draw it here, mark a point here, draw it in upward direction. So this A point, B point, so here is 40 for first cylinder. Immediately the second cylinder you should draw it. So no need to use the firing order. If you are using firing order, they automatically it is closed. So right, again it is a second cylinder, it is in upward direction, right? Next, immediately the second position, there are 2 cylinder, 4 and 3, right? So right, you should draw it. Similarly, it is 120 degree apart, 2 centimeter, right, up to here. Then it is B, C, it is third cylinder, again it is 40, it is a fourth cylinder. Next, fifth and sixth cylinder, right? From this, right, parallel, draw the line parallel to the angular position, right? Automatically it is closed. So automatically it is 4 and 4, 2 and 2, right? The scale 2 centimeter, 40, it is 40. So 40, 40, 40, 40, right? Right. So this is secondary for force polygon. So there is no secondary unbalanced force produced in this problem. So next you go to draw the secondary couple polygon, right? Secondary couple polygon is a very important one. So according to firing order, you should do it, or according to the cylinder position you should do it, nothing else, both are same, right? So according to the firing order I will draw it one, according to the cylinder position I will draw it, both are producing the same values, right? Okay, so first I take according to the firing order. So you know the firing order, that's nothing but 1 4 5 2 3 6, right? 1 4 5 2 3 6. So I draw the secondary couple polygon. I take 1, so it is upward direction, but here it is a negative, so it is downward, right? It is in downward, right? So now downward direction, it is 60. I take 6 centimeter, or otherwise I take 3 centimeter line. I draw the 3 centimeter line, downward direction, right? So A, this is B, that is minus 60, because it is cylinder is upward direction, you should draw the line in downward direction because the negative value, right? So next immediately second cylinder the value is minus 36, but it is in upward direction.